So there's what, this is the most technical part. We call it area of a regular polygon. We can only get area of a regular polygon with a formula. Others, you can't get it. You partition it. So, but before then, we need to learn what we call apodem and the radius of a polygon. So let's define that. The apodem of a polygon is the perpendicular distance from the center of the polygon to a side of the polygon. So if you move perpendicular, perpendicular means something that makes an angle 90. So this means angle 90, perpendicular. So the perpendicular, not just any other distance, the perpendicular distance from the center. So if you have the center of this polygon, so and you move perpendicular to a side, see the side, forms angle 90. So this is the apodem. So this is the apodem. Let's denote, let the apodem be P. Sorry, be A. Apodem is A. So the distance from this center O to this point is the apodem. So OA is the apodem, A. So that's it. And also we can still define it at the radius of the circle. If I want to inscribe this circle, see the circle in white. The radius is A. So the radius of an inscribed circle is the circle that intersects that touches each of the sides at only one point. So this is the inscribed circle. So if you don't call inscribed circle, the radius of the inscribed circle of a polygon, you call it the apodem. So that's for apodem. We now move to radius of a polygon. The radius of a polygon is the distance from the center to the vertex. So I'm saying that if you see the vertex, so this is the vertex, this is vertex, while this one is side. So look at the difference, the distance from the center to the vertex, this is the radius of the polygon. And why this A is the apodem. So that's the difference between the apodem and the radius of the polygon. We can still define radius of a polygon as the radius of the circumcircle. Yes. Inscribe is inside. Circum is the one that carries. Okay, let me just get. If you draw a circle, let me use red. So if I draw a circle, that passes through the vertices. So do you see it? This is now the radius of this circumcircle. This one outside is called circumcircle. This one is inscribed circle. While the one in red is circumcircle. So the radius of the circumcircle is the radius of the polygon, while the radius of the inscribed circle is the apodem. So that's it. And we need to get a formula for the areas. So we need to get a formula. If you notice, if I join, let me get this. Okay, look at this. You know, this is a regular hexagon. I will use a hexagon to prove that. If I join this, the vertices, you will notice that we will form 6 equilateral triangles. Yes. Let's join. You see. Or maybe let me change this to black. Let's change it to black. Let's change it to black. So let's join. We want to get a formula for that. We're almost done. So what do you notice? We have 6 equilateral triangle. Yes. Because this is a regular equal, so equal sides. This is the radius. Yes. We have 6 equilateral triangles here. So what am I trying to derive? I'm trying to derive that area of this regular polygon is equal to the area, the summation of area. That's the sum. This symbol sigma means sum. Sum of area of the 6 triangles. We'll have 6 equilateral triangles. And we know that area of a triangle is half base times height. So since I have 6 of them, if I know the area of one, I multiply by 6. So I have 6 times area of one of them, like this one. Area of a triangle is half base. The base, okay, let me call the side of this triangle, that's the polygon. Let's call the side. Let's call it x. So this side is x. This side is x. This is also x. So the side of the triangle or the side of the polygon is x. So our area will now be half times the base is x times the height is a. Yes. And you know multiplication is commutative. Yes. I can arrange this as half times 6x times a. And what do you notice? 6x means how many sides are here? 6. So if I sum, means the perimeter. So I can now say that the area of a regular polygon is now equal to half times the perimeter times a, which is the apple. So we've gotten the formula for the area of a polygon, a regular polygon. Half times the perimeter times the apodem. So I used a hexagon so that you can easily visualize that. Even if you use any other polygon, it's still correct. So let's solve this question. So this is the last 2 questions for this tutorial. So they said find the area of a regular pentagon of side 6 and apodem 8 cm. So without wasting time, the area of the regular pentagon is now half times perimeter. What's the side? Pentagon is 5 sides. So I have 5 times 6. As each of the side is 6 cm times the apodem is 8. So our answer is we're almost done with the answer. So I have 5 times 2 in 6 is 3 times 8. So 5 times 8 is 40. 40 times 3 is 120. So 120 cm squared. So that's the area of our regular pentagon. And this, whereas find the area of a regular hexagon if the radius of the polygon is 8 cm. So this is a technical question. Let me copy this. Know if I can copy. Let me use it as the solution. Okay. And let me still copy this so that you see what is happening. Okay. I'll use a side for this. Remember, the radius of a polygon is the distance from the center to any of the vertices. So I'm using this vertex A. And we know that the apodem is the distance, perpendicular distance perpendicular, so angle 90. So from here to here is the apodem. So, but they didn't give us the value. But we know that this is 90 degrees. And they said the side. Okay, they said they didn't give us the side. They gave us the radius of the polygon, which is 8. So with that, we can get the remaining. But remember, we need to get the central angle. That's where we come in, the central angle of this polygon. Okay, let me just add. Okay, so I want to get this, each of these, the central angle. Yes, this central angle. We need to, let's get it. So each central angle is always equal to exterior angle. And I told you, for a regular polygon, the exterior angle is 360 degrees over n. So we have 6 sides, so 360 over 6. So each of them is 60. So this central angle is 60. That's, we have 60 degrees. 60 degrees. But remember that, you know, this is an isosceles triangle or an equilateral triangle. The height bisects the sides and the angle. So the height is an angle bisector, meaning it bisects, divides the angle into 2 equal parts. So if here is 60, here is 30, and here is 30. So with that, we can get the remaining side because we are looking for the height. We need the height. That's the apodem. We need the apodem A. So, but before I solve it, there is an elementary theorem that will help us to solve this question. It's called 30, 60, 90 triangle theorem. To help us to get the apodem fast. Like I'm looking at it, the answer is 4 root 3. Yes. You'll be wondering how. How is it 4 times root 3? If you have a triangle that the interior angles are 30, 60, and 90, if the opposite, the side opposite 30 is x, just know that the one opposite 60 degree will be the x, the value here, times root 3. Square root 3. While the one opposite 90 will be 2 times x. So for example, if I have this side to be 30, this angle to be 30 degrees, and I have this side to be 4. Without wasting time, the one opposite 60 will be 4 times root 3. And the one opposite 90 will be 4 times 2, which is 8. So that's what we are going to use here. So since the one opposite 90 is 8, the one opposite 30 will be 4, from what I just explained. X to x. Why the one opposite this here will be 60? Since this is a triangle, this is 90, this is 30, so the remaining angle will be 60. Therefore, A will be 4 times root 3. Fast. Therefore, the area we are looking for of the polygon, the regular hexagon, the area is now half times, what's the side? 6 sides times each of them. Each side. Okay, from here, you see that here will be 4. Since this is 8, you know they form equilateral triangles. So the side here is 8. So this is also 8. So this is 8 times the apodem, which is 8. 4 times root 3. So our answer is now 2 in that is 3. 3 times 8 times 4 times 4 root 3.
We have 3 times 4 is 12. 12 times 8 is 96. 96. So that's the final answer, cm squared. So the question is is tricky. Thank you.